Hello, everybody. Welcome to Keysight Solution Tech Talk. My name is Elizabeth Fei. I'm from the Solution Marketing team. I'll be joined today by Dr. Di Lu, who has very rich experience on MIMO technology. Dr. Di, welcome to Keysight Solution Tech Talk.
Hello, everyone, and I am Dee, and it's my great honor to be here today.
We know that MIMO is an important innovation in wireless communication. Today, our topic is about the testing challenges posed by MIMO technology and exploring the potential solutions. So, let's get started. Dr. Yu, for the benefit of everyone, can you maybe explain more about what is MIMO?
Okay, and MIMO, or multiple input, multiple output, is a wireless technology that utilizes multiple antennas as both ends of a communication link to enhance performance. By transmitting and receiving a multiple data streams simultaneously, MIMO increases data rate, improves efficiency, and enhances spectrum efficiency. It achieves this by exploiting the spatial dimension, allowing for increased capacity and better resistance against fading or other interference in the cell. MIMO technology offers two main benefits. The first one is spatial multiplexing, which increases data rate, data throughput, and beamforming, which focuses the signal in specific directions to improve coverage and reduce interference to other users. Widely used in Wi-Fi, WLAN, or 4G and 5G network, MIMO has revolutionary wireless communication technologies by delivering high data rate, better network performance, and improved overall user experience. 5G NR further increases the number of supported antennas and reference signals in the standard. And massive MIMO, which refers to a large-scale antenna system, has also gained intensive commercial use.
Dr. Lu, what challenges do such a complex technology pose for testing?
Okay, when it comes to hardware, massive MIMO poses some challenges. It needs a lot of antennas and RF connections, which can exceed the current capacity of conventional RF instrument. The design of the antenna array is also crucial. Each antenna must meet strict phase requirement, especially in some scenarios involving data and beamforming. This means that signal weights across multiple antennas need to change significantly. Traditional phase shifting network might have difficulty handling such requirements. The complexity extends to signal processing as well. It involves verifying the effectiveness of beamforming, examining the beamforming factors for different antenna ports. Additionally, there are other aspects of signal processing that requires attention. It is essential to ensure that beamforming is working optimally and that the signal are processed accurately. Overall, or in one word, this complexity in hardware and signal processing needs to be carefully addressed to ensure the successful implementation of massive MIMO technology.
Right. Limitations in test instruments are not only an inconvenience to the test engineers, but the validations of the results will be questionable then. Dr. Ri, can you talk about the solutions about Keysight has to offer to test MIMO or massive MIMO?
We were talking about how MIMO, especially massive MIMO technology, brings unprecedented challenges to testing and measurement. With massive MIMO's use of large numbers of antennas, traditional RF measurement instruments need to be improved, especially in terms of channel counts. And impossible to measure all antennas simultaneously using the traditional RF measurement equipment. So we have to resort to using splitters or switch matrices as auxiliary equipment to measure antennas in batches, which isn't very efficient. And moreover, massive MIMO requires strict and phase coherent. That is, and the different RF channels need to be phase coherent. And it is difficult to verify in batches as well, and able to provide measurements for all beams directions using the traditional RF measurement equipment. So, and that's where Keysight's new MTRX testing solutions comes in, which greatly simplifies the verification of massive MIMO. The MTRX hardware comes in two models, E6464A and E6416A. And this one supports up to 64 RF ports, and this one supports up to 16 RF ports. And you can choose to install only a subset of the ports based on your test need. Each RF port of the MTRX can be used as an individual signal source or spectrum analyzer. So when it comes to RF and layer 1 testing, it is like having a powerful RF signal analyzer and the transmitter with up to 64 or 16 channels or phase coherent. The MTRX solution allows us to analyze the signals of downlink beams, generate signals for uplink beam transmission, perform bidirectional testing, and test beam mobility.
What is a specific testing method or process for certain testing scenarios? And how do we evaluate the performance of the system?
This is a very good question, and we have prepared a special demo to explain this set of solution in detail. So let's take a look.
Okay,
now let's start our demo. This is our demo unit. It's multiple transceiver and RF test set. So we just talked about that we have two model types. One is 64 channels and this one is 16 channels. We can see from the front channel that this unit is fully configured. It has 16 channels. We have TRX1 to TRX16, 16 RF channels. But you might asking that why there are 32 connectors in the front? Because for the old number RF connectors, they are transmitting and receiving signals at the same time. So they are bidirectional and RF ports. But for the odd number RF connectors, they are for transmitting signals only. So it gives our customer the flexibility to use either bidirectional or unidirectional connectors for their test unit. Okay. So this unit, you can think of it like a mainframe without a display. So we need to connect a display and a digital display port to display. And now this unit is fully started. This is the UI of MTRX. So we're going to do a receiving demo. So that is we are going to use VSA to analyze beamforming signals. So I will make a new config from the beginning. So we click this plus icon, and because we are doing an analyzer thing, so we need to select the analyzer. So we can name it as anything that you want, because like we can name as massive MIMO, and then we select the number of RF inputs. We are going to do a 16 channel models demo, so we will write 16 RF inputs. And then we can choose the bandwidth between 100 megahertz and 200 megahertz, and then click OK. And now this state is not activated yet. We need to activate the state. So you can see that TRX1 to TRX16, so all these 16 channels the light is blue. Okay, so that's it for the UI. Then we are going to move on the VSA analyzing part.
So let's see a demo that's showing how we use MTRX to analyze the beamforming or to test the RF parameters for the DUT. So all the analysis is done in VSA. So in VSA, in this demo, I'm playing back a base station downlink signal that was recorded before. Now here you can see what all can be seen in one measurement. What's shown on this window is only part of the information that could be shown or that could be provided by VSA. Actually, if you navigate through the windows, you can see some more information, and you can choose any information that you want for each individual window. So, and this measurement is running continuously within the length of the recording, and it is frequently updating itself. So if you are connecting a real DUT or a real base station, so the test will be real time. So with this signal, we are having a PDSC H beam pointing to 0-degree direction. You can configure the screen. In this case, if you want to see the beam measurement and direction information. For example, the azimuth peak and elevation peak, and also the beam width and the peak power. So we can also see the results for some RF parameters, like for the EVM results for each individual physical channels, the SNR for each different channels, the power per AE for each channels, as well as the demodulation scheme that are used for each individual physical channels. We can also see the spectrum, the frequency response. In this case, we have 16 channels measurement. So we can also see, we can also configure to see the beam weights for each individual channel. And also, all the parameter setting up is done in this demodulation property. You can choose what channel you want to visualize. In this signal, actually, we also have SSB included. So if you tick the SSB on, you can immediately see the results of SSB beams, the beam pattern, the beam weight, or the beam direction, and or the beam summaries on the screen. So if you change your parameters and configure or update your base station or your DUT, the beam weights for each different channels, you can immediately validate your algorithm in VSA within the multiple channel MTRX.
Thanks so much for your explanation through the demo. To close this discussion, what do you think is the realistic outlook for MIMO for the future years down to the road?
Okay, and in my opinion of view, the future outlook for MIMO technology is highly optimistic. As we move forward, MIMO is expected to play a vital role in shaping the wireless communication landscape. With the advent of 5G and the continuous development of wireless technologies, MIMO will continue to evolve and offer substantial benefits. Massive MIMO, with its ability to utilize a large number of antennas, will drive improvements in capacity, coverage, and spectrum efficiency. It will enable higher data rate, enhanced network performance, and cater to increasing demand of bandwidth-intensive applications. MIMO will also adapt to support emerging technologies and applications, such as Internet of Things, IoT, smart cities, and automobile vehicles. By optimizing spectrum utilization and improving advanced technologies like beamforming, MIMO will enable reliable and high-speed wireless connectivity in various scenarios. Ongoing research and development efforts will further enhance MIMO's capacity and ensure its compatibility with future wireless standards. So overall, to summary, MIMO holds great potentials for transforming the way that we communicate, enabling faster, more efficient, and reliable wireless connections in the years to come.
Dr. Liu, thank you so much for participating and providing some interesting insight on MIMO technology and solutions. We hope you find this section is very insightful for you, and thank you for joining us today.